Let's talk about similarity between three-dimensional figures. Okay, so, and we've talked about this before. Let's say that this two figures have a scale factor of A over B. What does that mean? Well, let's use maybe a numerical example. If I were to say that this, from this prism to this prism, if this is 3 times bigger than this, the scale factor would be 1/3, right? That's our scale factor, is whatever we multiply this by to get to this, that's the scale factor. But what does it mean for a three-dimensional figure to have a scale factor of 1/3? Does that mean that the volume is 3 times larger? Does that mean that the surface area is 3 times larger? Well, when we talk about scale factor, what I'm saying is that the side length here is 3 times larger than the side length here. So if I were to, again, just for an example, if this base was 6, then the base over here would be 2, right? This base is 3 times larger than this base. That's what we mean when we say that two prisms have a scale factor of A over B. Okay, so the ratio of the lengths then is always, no matter what, if it's a base edge, it's A over B. A lateral edge, so any edge of the base is A over B. Any edge of these rectangles is also A over B. If we were to have something like a cone or a cylinder, the radius would be A over B. Slant heights, A over B. Heights, A over B. Perimeter, still A over B. So any corresponding lengths in the figures are A over B. I felt like that guy in Parks and Rec. If you've never seen Parks and Rec, it's a great TV show, but they have someone come from a foreign country and he just says, he keeps saying all these different things that people do, and then he says, straight to jail, straight to jail. Anyways, when I was saying A over B, I just felt like that. So again, scale factor, if I say that two figures have a scale factor of A over B, that means that their side lengths have a scale factor of A over B. Okay, so what does that mean for area? Let's look. The ratio of area between two figures. So remember, we're saying we have a scale factor, the scale factor of A over B. So let's just look here. Let's say that my base, I don't know, we'll call the base X, I guess, because we're already using A over B. So let's call that base X, and let's call the height H. Then over here, well, what's the base and the height? What are the base and the height? Well, it's whatever this is times the scale factor. So here, my base would be X times A over B, and my height would be H times A over B. So let's write that out. So the area of the base, we'll call one base 1, is base times height divided by 2. So X times H divided by 2. And that's the area of base 1. The area of base 2, on the other hand, is X times A over B. That's my base. Times H times A over B divided by 2 still. And if we simplify this a little bit, we can combine A over B times A over B. We get A squared over B squared times X times H, times H divided by 2. And so let's compare these two bases. Right? If we were to create a ratio between base 1 and base 2, base 1 over base 2 would be x times h over 2 over well, we really want to say that this is base 2 to base 1 because that's, remember the scale ratio is the opposite of the scale factor, so sorry about that, but let's say that this is base 2 over base 1. Okay, so that's x times, a squared over b squared times x times h over 2 over x times h over 2. Now, if you go through all the math, then what ends up happening is we end up canceling out, the x's cancel out, the h's cancel out, and the 2's cancel out. So then the scale factor between these two bases is a squared over b squared. So the base areas then have a scale factor of a squared over b squared. And again, no matter what area we're talking about, it's always going to be the same. A squared over b squared. Total areas, a squared over b squared. Any areas, straight to jail. Just kidding. A squared over b squared. Seriously, Parks and Rec, check it out. Okay. No matter what area you have, it's a squared to b squared if the scale factor is a to b. Okay, so we said that we have the scale factor. That's a over b. We've got the ratio of areas. That's a squared over b squared. So maybe just think, what do you think the ratio of volumes is going to be? Well, let's check it out. Remember, let's do two different colors here. Let's maybe do, I don't know, green and pink. Why not? The volume of my first figure is 1/3 the area of the first base times the area of the height. So again, let's kind of use what we did in our last problem. Here's the height, and here is the base of that triangle. So, sorry, I don't know why I like to put 1/3 for no reason. It's a prism, not a cone, so, or a pyramid. This is base 1 times height. So much easier. Okay. So the volume of 1 is base 1 times height. Again, that's x. Here's height. So that's equal to x times h divided by 2 times, and this is really the height of my figure. So maybe we can use like a big H. I know it's just hard when we're using, so this is big H right there, times big H. Okay. And let's do the same thing that we were doing in the other problems, right? Remember, the scale factor is a to b. So here we go. This is x times a over b. This is h, little h, times a over b. And this is big H times a over b, right? Because that's the ratio of the lengths. So then the volume of my second figure is x times a over b times h times a over b divided by 2 times big H times a over b. And okay, so let's simplify that a little bit. We end up with a over b times a over b times a over b. So we have a cubed over b cubed times x times h times big H divided by 2. And if you notice, that's what we've got up here, right? This is x times h times big H divided by 2. And so just like in the last problem, if I'm taking the scale factor, volume 2 over volume 1, that's equal to all of this, a cubed over, sorry, that should be b cubed over b cubed, times all of this, x times h over 2, over x times h over 2. And so these two pieces right here cancel out, leaving me with a ratio of volumes of a cubed over b cubed. And that's just all based on using a scale factor of a to b. If you were really feeling smart, you could have said, I know that the ratio of areas is a squared to b squared. So base 2 automatically has a ratio. Base 1 to base 2 has a ratio of a squared to b squared. And then you could use that to go forward and kind of take one step out. Or you could do this way, where we use just the side links. So that is the explanation of when we talk about two three-dimensional figures. If I say it has a scale factor of a over b, or a to b, that means that we're comparing the side lengths. Because the ratio of areas then would be a squared to b squared, and the ratio of volumes would be a cubed to b cubed.